Good morning, guys. So today's assignment is going to be for you to read through this information um, on this page and answer some questions in a Schoology activity to show that you read it. So I wanted to just kind of go through it with you in a video in case you don't come to Zoom and miss some of the excuse me, other information that we talk about. So at the top, it says our solid surface called the crust, which is part of the lithosphere, is broken into pieces called tectonic plates. These plates fit together like a jigsaw puzzle and move around slowly on the semi-molten layer of the upper mantle called the asthenosphere. These tectonic plates interact in several different ways, producing much of Earth's topography. Topography is the mountains, the valleys, the flatlands. It's basically the physical look of how the Earth is. Tall mountains, shallow valleys, deep ocean trenches, etc. But before we dive into the types of plate boundaries, we need to make sure that we understand that there are two different types of crust. The first type of crust is called oceanic crust, and of course, based on the name, we should know that this is the crust that is found at the bottom of the oceans. It is younger, it is cold, and it is dense. And when we talk about what dense means that the molecules that make up this crust are extremely tightly packed, so there's not a lot of empty space or space for air to collect in there. It is made of a metals-rich rock called basalt. Oceanic crust is found at the bottom of the oceans and sometimes found in mountains, and that is one way we know that rock is moved through plate tectonics. So, for example, if we look through rocks here in San Antonio, we will find fossils, and the majority of those fossils that we find here in San Antonio are fossils of sea creatures. Even at the top of Everest, the tallest mountain in the world, the fossils that are found on Mount Everest and other mountains in the Himalayan mountains are fossils of sea creatures. And that suggests that millions of years ago, the rock that now forms the Himalayan mountains used to be at the bottom of an ocean. So, since ocean crust melts and forms through plate interactions, it can be quite young, anywhere between 0 to 200 million years old. And I know when we say young, 200 million years does not sound young, but in the history of the Earth, if we look at the history of the Earth, 200 million years is very young as rocks go. The other type of crust is called continental crust. It's typically silicone rich, which is a much lighter element and older, but it is lighter. And I don't know if I would use the word fluffy, it's just less dense. So there's more empty space inside those rocks, more space for air pockets to form. Continental crust is typically found, of course, in the continents and can be even billions of years old, billions with a B. So when these two types of plates interact, continental crust will always float over top of the oceanic crust. And this is really important because this is a process known as subduction. And subduction occurs where one plate is pushed underneath. So if you look at these images over here on the left, or actually all three of these images, you'll notice here that when these two plates are coming together, that this plate goes underneath. Okay, so this is the process known as subduction. Same thing here. Again, subduction is occurring, and same thing here. Subduction is occurring. Now, depending on where that subduction occurs, if it occurs out in the ocean, we can get things like island arcs, and we get this trench that's like right there, a little deep trench. If it occurs right at the beach, so to speak, right where the continent and the ocean are connecting here, then we get those same volcanic islands, or the same volcanoes are forming, but instead of forming in the ocean, they're forming here on the edge of continents. And we see that here in the Pacific Northwest of the United States with the Cascade Range. And then here, if two continental crust plates are colliding, we get the mountains, we get the wrinkling or the crumpling, so to speak, of the Earth's crust, which forms mountains. but we don't get the volcanic activity. We just get the formation of the mountains. Okay, so there are three main types of boundaries. Convergent, these are boundaries that occur when plates move into each other or converge or come together. Divergent, these are boundaries where tectonic plates move apart from each other or diverge. These boundaries produce magma and volcanoes as the plates leave an opening for the mantle to come up from inside the earth. And then the third type of boundary is the transform boundary. And these are where tectonic plates are scraping past each other without moving apart or together. So this is an example right here of a transform boundary where the two plates are sliding past one another. And so that will still cause different kinds of land features, which we'll talk about as we move through this week. But on every single one of these interactions, you're going to find earthquakes. Okay, earthquakes occur everywhere two plates meet. So here's a little chart that kind of breaks everything down pretty succinctly for you. We have the types of boundaries. So continental, oceanic, and oceanic. These top three are all convergent boundaries where plates are coming together. And depending on what type of plate is colliding with the other type of plate, we can have some very different results or effects from that. So when two continental plates collide, usually it's the older crust that will sink, and we do get tall mountains and earthquakes from that. When an ocean and a continental plate collide, we have the dense oceanic plate sinking, which again is subduction, below the more buoyant or less dense continental plate. So that subduction then creates volcanoes and a trench, and again, always earthquakes. When two oceanic plates collide, the older of the two plates is usually the more dense, and that is the one that's going to subduct. Volcanoes, trench, and other earthquakes can also occur, and these volcanoes would be islands if it's two oceanic plates. Divergent boundaries, the plates can pull apart, allowing magma to ooze up in between. The formations that we get are the mid-ocean ridge. We get some volcanoes and, again, earthquakes. And then the transform boundaries, which is the one that we see in California, the San Andreas Fault, where two plates are sliding past one another, can create earthquakes. All right, so that's basically all the information that you need in order to complete today's activity. As we go through the rest of the week, each day we'll pick a different type of boundary and talk about the tectonics or the physical processes that are going on, and then what the results or effects of those processes are on the Earth's surface as it relates to either geologic events, which is a review from 6th grade, or landforms that are formed on the Earth's surface, which is our main focus for 8th grade. All right, guys, as always, if you have any questions, please let me know. Y'all have a great day.